Hello everyone, and welcome to Gefran's webinar, GTF SCR Power Controller for electric heating loads. My name is Matt Fisher, and I'll be your presenter today. A little bit of housekeeping. We'll begin by muting everyone so that we can provide the best audio experience possible. We apologize in advance for any technical issues that may arise due to the large demands placed on the internet services under the present conditions and its large use. Thank you for attending, and let's begin. I'd like to take just a minute or two and provide a simple review of electric heating, what it is, who uses it, where it's used, and why it might be used. We'll follow that with a couple of brief examples, and then review benefits and features of the GTF Power Controller. So let's get started. So what is an SCR Power Controller? An SCR Power Controller is an electronic semiconductor device designed to switch power at its output connection rapidly and efficiently. There are two primary methods of adjusting power. Full cycle conduction, where we adjust full cycles over a time period, or angle of conduction, where we adjust the angle of conduction within a full cycle. Okay, now let's look at who uses electrical heating. Electrical heating is used in a variety of industries, such as the aircraft industry, automobile manufacturing industry, the defense sector, glass industry, in oil and gas, heavy machinery manufacturing, and plastics industries, to name a few. Where is electric heating used? In metal heat treating and processing. Typically you'd find this in furnaces and ovens. For composite material manufacturing, in autoclaves, for example. In glass manufacturing, could be found in flat glass production, glass bending and tempering, and electric booths for glass production. Oil and gas, typical use is the heating system for offshore platforms. And in plastics, extruding, forming, and molding. Now let's look at an electric heating application example. This is an automotive example. An automobile is made up of many components, and several of these components utilize electric heating in their manufacturing processes. For example, glass, windshields, side panels, sunroofs, rear panels, all use electric heating in their manufacturing process. Metal components such as springs and gears and other metal parts in the automobile. In rubber manufacturing, typically tires and mats, seals and gaskets, and in plastic manufacturing for headliners, floors, and door panels. Why use electric heating? Well, there's several reasons that we might use electric heating, and a few of them are listed here. Let's take a look at them. Lower safety concerns. Compared to other methods of heating, there's no open flame. Electric heating can be rated for use in a hazardous location. And the SCR Power Controller is located inside an electrical panel, providing safety from incidental contact. Electric heating has simplified maintenance. There's limited maintenance required. Generally check terminal connections yearly and check that the fan is operational and functioning if there is a fan for the power controller. Monitoring and diagnostics. Compared to other methods, the SCR Power Controller can provide integrated continuous real-time status and alarm indication. It monitors things such as voltage, current, power, load impedance, and frequency, for example. Electric heating also is sustainable. It's a cleaner operational process and has lower installation costs. There's no fuel lines, combustion exhaust stacks, or holding tanks. It's a reduced environmental impact process. It can be put in line in a production flow. Electric heating also provides precise temperature control. It has point of use installation. The energy that it provides is converted to heat without waste and can provide tight temperature tolerances compared to other methods, sometimes to within a degree or tenths of a degree based on the application. Here's an example of a GTF single-phase linear load application. Typically might be a tempering furnace or oven with a resistive element, our programmable logic controller, programmable automation controller, or PID controller provides an analog control signal, does a simple voltage control output, maybe burst firing or zero cross to the heating load, and controls the temperature. Next is an example of a single-phase application with infrared lamps, which are nonlinear resistive heating elements. This application uses an analog control signal applied from a programmable logic controller, programmable automation controller, or PID process controller. The load uses a soft start ramp, current limit, voltage, current, and power feedback, and heater break detection. Here we have a third example showing a three-phase application with multiple heating elements and multiple zones of control. The heating elements used for this application have different voltage ratings and use both series and parallel connections. The heaters represent nonlinear loading and are monitored and controlled by a Modbus RTU digital communication link. The application uses a soft start ramp, current limit, voltage, current, and power feedback, voltage limit, and heater break monitoring and alarming. As we can observe in this example, Zone 1 uses 4 heaters rated at 115 volts each, connected in series for a total voltage rating of 460 volts. Zone 2 uses 4 heaters connected in parallel with a total voltage rating of 480 volts AC. Taking a look at Zone 4, we find that the zone uses 3 heaters rated at 115 volts each, connected in series for a total maximum voltage rating of 345 volts AC. And Zone 5 is similar to Zone 2, but has 3 480 volt rated heating elements connected in parallel. Now let's talk about the GTF SCR Power Controller. It's a universal modular power controller suitable for all electric heating loads. Has a configurable operation or trigger mode capability, so we can control in zero cross, burst firing, half single cycle, and phase angle. It also has a configurable output or control mode, so we can control voltage, voltage squared, current, current squared, or power. Provides process integration connectivity through Modbus RTU communications. And has conformity to CE, CSA, UL, and TUV, and also 100,000 amp 600 volt SCCR RMS symmetrical rating. The GTF Power Controller is one family of power controllers, 2 frame sizes, as we can see here in the pictures, 3 voltage ranges, 480 volts, 600 volts, and 690 volts AC, and current ratings from 25 amps to 250 amps. Here we can see the GTF Power Controller dimensions for the 2 frame sizes. On the left we can observe the smaller frame size for 25 amp through 120 amps, and then on the right the larger frame size from 150 amps to 250 amps. So output control of the GTF can be provided from an analog signal through your programmable logic controller, programmable automation controller, or PID controller, or simply via a potentiometer. Set the value and forget it. It can be also digital using a pulse width modulation signal, and also via field bus by Modbus RTU from your programmable logic controller or programmable automation controller. Some of the benefits of the GTF is it can work with linear and nonlinear loads. Linear load might be a nichrome or an iron chromium type element. Nonlinear loads such as silicon carbide, molybdenum disilicide, and nonlinear elements such as shortwave infrared lamps. The GTF Power Controller provides complete monitoring and diagnostics. It monitors voltage, current, power, and temperature, and has multiple alarms. From the snapshots shown, we can see the GTF monitoring frequency, voltage, current, power, and impedance. Also, we can see the alarm conditions including over temperature, short circuit, heater break, no voltage, and no current. The GTF Power Controller has a heater break alarm function. The heater break alarm function can detect partial and total heater failure conditions. The heating zone may have series or parallel connected heater elements. The GTF will monitor the power output to determine a condition of partial or total load loss. The GTF features a self-learning function to automatically adjust and record the heater break alarm set points. The GTF Power Controller has onboard LED lights. These LED lights provide visual confirmation of the GTF operation. LED status indication includes run, auto manual, an alarm condition, the energized or de-energized status of the digital input, the thyristor on state, and an over temperature condition. Another benefit of the GTF Power Controller is the monitoring of the internal GTF semiconductor temperature. The GTF has an over temperature alarm that provides automatic shutdown of the power controller output if an over temperature condition is detected. This prevents the SCR power controller from destroying itself. So why is heat a consideration? The ability of any SCR device to drive its output is reduced in relationship to its semiconductor temperature. What does that mean? It means that as it gets hotter, the power controller current output is reduced. Shown here is a set of derating curves for the GTF SCR Power Controller. We can see that above 40 degrees C or 104 degrees Fahrenheit, the power controller has a decreased value for its output. The GTF Power Controller is rated for full output through 40 degrees centigrade, 104 degrees Fahrenheit. It's important to understand that all SCR power controllers dissipate heat energy in watts. It is approximately 1.3 to 1.5 watts per ampere of current that the SCR controls. Quite often, multiple SCR power controllers, along with other heat-generating electronics, are installed in electrical cabinets. The electrical cabinet should have proper ventilation or cooling to keep the internal cabinet temperature from getting too hot. For example, a 100 amp single-phase power controller dissipates 130 to 150 watts at full output of 100 amps. This means approximately 440 to 510 BTU per hour per power controller. So looking at the picture here for this installation, for 36 power controllers, if they're all driving their output at 100 amps, this would equate to approximately 18,000 BTUs per hour. One of the benefits of the GTF power controller in the larger frame 150 amp to 250 amp power controller is that it additionally monitors the temperature of its incoming and outgoing power terminations. This is important because it can alert you to potential problems prior to the terminations becoming a major issue or a point of failure. GTF power controller can provide voltage, current, and power feedback. This capability allows the GTF to be set up to control the heating elements to the manufacturer's recommendation or requirement. Power feedback provides regulated output by power. For example, silicon carbide elements might use power control. Current feedback provides regulated output by current. For example, molybdenum and graphite elements might use current control. Voltage feedback regulates the output by voltage. Examples might be nickel chromium or iron chromium type elements. The GTF has soft start capability. It has a specially developed and dedicated curve for shortwave infrared lamps. It allows the lamp to gradually warm up prior to a higher power, which increases the lamp life. The GTF power controller has an overpeak current limit when using the half single cycle firing mode. The overpeak current limit function keeps the infrared heater from being exposed to very high currents at the end of the soft start ramp at the beginning of the complete half cycle wave. This feature increases lamp heater life and eliminates peak overcurrent fuse trips. The GTF power controller can be integrated into the automation system. So your programmable logic controller or programmable automation controller can interface with the GTF. It features standard RJ10 plug-and-play connections. This digital communication link supports the Internet of Things, Industry 4.0, Smart Factory, data analytics, and predictive maintenance for today's tightly integrated process automation systems. The GTF power controller can interface with your programmable logic controller or programmable automation controller directly via Modbus RTU or through a gateway device via other protocols. Shown in this example is a Gefran 1850 controller that can be a Modbus RTU TCP bridge connecting up to 15 Modbus RTU devices. The order code for a GTF power controller is a sequence of features, options, and control selections. The GTF can be specified for current requirements, voltage requirement, various optional functionality, and control selection. Features include current limit, voltage, current, and power feedback, heater break alarm, self-contained fuse for 150 amp to 250 amp power controllers, and with or without Modbus communication. The last three characters in the order code indicate the control signal input, the trigger mode, and the function for single-phase or three-phase applications. This can be ordered directly at the beginning and also can be changed to meet the application requirements using Gefran's programming utility, GF Express. The factory default is 1BM, indicating 0 to 10 volts DC input, burst firing, and a master functionality. The GTF power controller can be configured for the application using Gefran's GF Express configuration utility software. This software is common to programming all Gefran devices. It is a free download from the Gefran website. For the GTF power controller, the software requires one of two cables. Either a cable for configuring when the GTF has no Modbus communication, or a cable for configuring when the GTF has Modbus communication. The GF Express software provides programming access to the GTF Power Controller. It can be used offline and online with the device. Shown here are snapshots of the parameter list with all of the parameters and the wizard for setting up the configuration. The GTF Power Controller is one family of Gefran power controllers. The GTF Extra is similar in functionality to the GTF. It features an integrated overcurrent fault protection, which replaces the high-speed fuse requirement. It is rated for 480 volts AC and 25 to 60 amp current range. The GFX4 and GFX4IR is an integrated package featuring 4 independent PID control loops. The GFX4 and GFX4IR can use its PID control loop or be configured to work with a PLC or programmable automation controller. It is rated for 480 volts AC and 16, 30, and 40 amp current applications. It's DIN rail mounting or can be panel mounted. It has field bus communications options such as Ethernet IP, Modbus RTU, Modbus TCP, Profinet, Profibus, and EtherCAT. The GFW is a full-featured modular power controller. It can be set up for single-phase, dual-leg, and three-phase applications. It monitors SCR and power terminal temperatures. It can be rated for 480 volt, 600 volt, 690 volts, and 40 to 600 amp current applications. It has field bus communications of Ethernet, Modbus RTU, Modbus TCP, Profinet, Profibus, EtherCAT, and CAN Open. The GFW Extra is similar to the GFW. It has an integrated overcurrent fault protection, which replaces the high-speed fuse requirement. It's rated at 480 volts and 40 to 100 amp current. In summary, the GTF is a compact power controller. As we saw earlier in the presentation, the GTF power controller is a tightly packaged power controller with a great deal of functionality. It's scalable. The GTF power controller is scalable to meet current application requirements from 25 through 250 amp and voltage requirements of 480 volts, 600 volts, or 690 volts AC. It can be used in single-phase, dual-phase, and three-phase applications. The GTF power controller is flexible. It has multiple operating or firing modes and multiple feedback and control output configurations to meet the various heating element control requirements. It has the capability to be controlled by an analog signal, a pulse width modulation signal, or by an automation controller using a Modbus RTU digital communication interface. On behalf of Gefran, I would like to thank you for attending this webinar. If you would like additional information, please contact me at your convenience at matthew.fisher@gefran.com or contact your regional sales manager or Gefran directly by phone, toll-free at 888-888-4474 or through the Gefran website, www.gefran.com. Thank you.